What method are you going to try to use on this? U-substitution. What do you think U should be? Yeah, 1 plus cosine squared x. Tacking on constants is okay because what's the derivative of a constant? 0. So you have du is 2 cosine x times what? Times negative sine of x. dx, correct. So what does dx equal? Du over negative cosine x sine x. Is there a 2 in there somewhere? Where's the 2? At front, right? So what do you do after you differentiate? Substitute it in. So you end up with the integral of sine x over what? U times, and now you're substituting. We'll just put that negative 2. Oh, it's not negative 2 out here. What should I put out front? Negative 1/2. Cosine x times what? What cancels? Sine x cancels. And what do you get to here? Negative 1/2 integral of what? U to the what power? Negative first times what? Times 1 over cosine of x times what? Du, right? I'm not asking the next. Do you agree that that's what we end up with if we do that substitution? Do you agree?
Yeah.
Okay. What's the problem at this point? No, the u to the negative 1 is not the problem. The 1 over cosine by itself is not the problem. 2 variables is the problem. Having 2 variables is the problem. 2 variables. Nope. Nope. No. If you see an integral with 2 variables, you do not know how to do that. You can't do that right now. That is not something you can do. So I will tell you that all of the algebra has been correct so far. So if we hit a wall here, what's the thing we're going to have to change? We're going to have to try a different U substitution. So you want to try U is equal to sine x. Let's see what happens there. What does du equal? Cosine x dx. So what does dx equal? Du over what? Cosine x. So now we substitute. So what do you end up with? U over what? 1 plus what? Cosine squared x. What's du over what? Cosine x. Well, does anything cancel here?
No.
Does anything cancel here? What do we think? Oh man, doesn't seem like it seems like we're stuck again. Any ideas? What's still the problem? 2 variables, and it's ugly. And it's ugly. I mean, at least on the other one, it kind of looks like maybe there's something cool we can do there, right? On this one, does it look like there's something cool we can do?
No.
You have a cosine cubed in that thing. Do you know anything about cosine cubed?
No.
No. Nor should you at this point in your math career. Cosine of x and see what happens. So if u is equal to cosine x, so what's du going to be, Fawn? dx. So what does dx equal? Du over negative sine x. And this is actually going to give us something nice because what are we going to get to cancel? Yeah, we end up with this. 1 plus what? U squared times what? Du over what? Negative sine x. Is that good? Yeah, that's good. Now, what's different this time? When we did it before, we ended up with that cosine still stuck there, right? Because we had to use, when we differentiated, what do we have to use there? We had to use the chain rule right there. So what cancels here? And there's a negative. So what does this become? Negative 1 over 1 plus u squared du. Not Fawn, someone else. Tell me, what is that? Yep. Negative tangent u plus c. That is the derivative of tangent right there. What was u? Cosine x. So what does this equal? Negative tangent of cosine x plus c. There it is right there. Tan inverse. Sorry, I didn't put the little thing there. Tan inverse. Tan inverse. Yes. Tan inverse. Absolutely. So just if your first U substitution doesn't work, try another. There really are only 3 candidates on this, right? You're either going to try sine, cosine, or the whole thing. Honestly, if I saw this without having done this 1,000 times, I would have done 1 plus cosine squared first. But do you run into a problem? Yeah, absolutely. What's at least nice about this is this a good sign that you're canceling? Yeah, but are you canceling everything? No. You have to cancel everything out of there. Everything out of there. Okay, so this one looks a little challenging. What did you try first? What do you think I would try first? Yeah, I would try 1 plus x to the fourth first and see what happens. What does du equal? 4x dx. So dx is equal to du over. Now we substitute, and what do we get? X over u times du over. What can we factor to the outside? What can I factor out? 1/4. And it ends up being what? What cancels here? You end up with u to the what? X to the what? -2 du. Is there a problem? Yeah, there's a problem. 2 vars. 2 vars. That is a problem. So this is a great idea. So what does du equal? 2x dx. What does dx equal? 2x. So what do you end up with? X over 1 plus squared times du over 2x. What cancels? Did you find it again? What did you find, Biggie? Yeah, so what is that? What is that? That is tangent inverse of u plus c. So what does this equal? Tan inverse of plus c. You figured it out. Good. That was great. Good job. That was very, very good. What u substitution did you make? U equals tangent x. Good. So du is equal to secant squared dx. What does dx equal? Du over secant squared x. Okay. So let's do this here. E to the what? U power over cosine squared x times du over. What is secant? So what does that do? That's e to the u cosine squared x over cosine squared x du. So what cancels? Is that really nice? So what's the integral of e to the u? So this is e to the u. So the integral, the general antiderivative, the indefinite integral. The indefinite integral is going to be e to the what power? Tangent x. And you're evaluating that from what to what? 0 to pi over 4. So you do e to the tangent of pi over 4 minus e to the 0. What's tangent of pi over 4? What's e to the 0? 1. So that's it right there. There's some small mistakes you can make in there. I'm looking for the bones of the problem right now. Yeah, but I have one question for you. You'll notice, what did I not write in the middle line right here? What did I not write in? I didn't write in C, and that's okay. That's just out of practice. But what's definitely not missing? I didn't write something in.
You didn't write in the big F, like the actual equation?
What do you notice is missing? Limits of integration. So I have a question for you. We substituted in for u. So once everything is written in terms of u, is it proper? This is a question. Is it proper for me to write this? 0 to pi over 4. Is that proper?
No.
Why not? Well, no, we're finding the indefinite first, but what I'm saying is if this is now in terms of u, what were these values originally in terms of? These are what? Both of these are what values? These are x values, right? And I wish I could write. Those are both x values, correct? Are these, but now what are we writing it in terms of? U. What does u equal? Tangent x. So if we were to write the limits in, what's tangent of 0? Tangent of 0 is 0. And up here we have to do the tangent of pi over 4. What is tangent of pi over 4? 1. What's tangent of 0? 0. Okay? So one way you can write this is, what did we do? We went in and we got our general antiderivative. At this point, what did we do once we got the answer being e to the u? We substituted back in, right? And then we evaluated from, because now we're in x land, right? We evaluated from 0 to pi over 4. But let me show you something that makes this a little simpler. Right here, this is the same as integrating from, what's tangent of 0? 0. What's tangent of pi over 4? 1 of e to the u du. What's the answer to this? Integrate this. What's the integral of e to the u? E to the u from 0 to 1 is e to the first minus. Is it the same answer? Yeah, it's the same answer. The point is, if you change your limits of integration once you substitute, you do not have to substitute back in for u. You see how we change the limits right there? If you change the limits of integration when you do the U-substitution, you see how we substituted back in right here? Do you have to do that? No.
But you still get the.
You get the same exact answer.
You have to do the same work though.
Kinda, but not always. Sometimes substituting back in, you're gonna have to end up doing the same work. Did we functionally do the same work? Yeah, we had to do tangent of 0 and tangent of pi over 4. In my opinion, and I think you will share this opinion, breaking things down to smaller pieces instead of doing it all together will be very, very helpful for you. In this case, does it really make too much of a difference? Not really. But just realize, if you substitute for u, if I were to write 0 and pi over 4, is that correct? No. If we're in u, you have to write u values. You have to write u values. I didn't write it here because, like, what are we writing in terms of right now? There's still x's in it, right? Yeah. So it's kind of ambiguous. You can make the case that it's written in terms of u because these will cancel out. But until I just have u's, I don't usually write it in until I just have u's. It will make a difference down the road. It will make it. This is going to be an integral. They gave you 5 answers, right? What's the width of each rectangle? Where is the width? This is the width, right? What are each of these? These are each of the heights, right? So where's the integral starting? What is that really close to? 0. And what is this equal to? 1. So you're definitely going from 0 to 1. What's the function definitely going to be? X to the what? 1/2 dx. There it is.
It's not.
That's it.
50, right?
Well, the 1 over 50, does the 1 over n fit in anywhere in the integral expression? No, it's not. This right here would be the limit as n goes to infinity of the summation of what? I equals 1 to n of what? 0 plus I over n to the what power? To the 1/2. So in this case, what did they just choose for an n value? Yes. This approximates this. Is this equal to this? No, it's not equal to it because for it to be equal, instead of 50, you'd have to have a limit as n goes to infinity. The reason this is equal is because you're taking, how many rectangles are you adding together here? Oh, I'm sorry, there's one thing that's missing here. We did the height. What are we missing? The width, I'm sorry. The width. The width right here. What's the width? Yeah, 1 minus 0 over n. In the general case, this expression right here, it's n. But in here, what is it? So is this going to be exactly equal to this? No. Is it going to be pretty close? Yeah, because how many divisions did you make? You made 50 divisions. You made 50 divisions.
So the 1 over the width has nothing to do with the...
No, this just tells you that you've made 50 here. It just tells you you've made 50 divisions. That's it.